Howdy. I have just been watching this video about the Canlaon volcano from GeologyHub. It's about 1 hour ago, or 1 hour old. And I noticed something once again, which is shown here somewhere. Yeah, I think here it is. I won't play this video here on YouTube. I will put the link below. You can go and check it out for yourself. But I took a screen recording. Let's put out off the sound and we go to the beginning of that. But before we'll take a look at this, here's the eruption starting. I just wanted to ensure that we are on the same page all together. NASA, science, nasa.government. All right. How do clouds form? Clouds are created when water vapor, an invisible gas, turns into liquid water droplets. These water droplets form on tiny particles like dust that are floating in the air. A camera on NASA's Terra satellite captured this image of clouds over the southern Indian Ocean. NASA and JPL Caltech. All right, here we have the clouds. You hang up a wet towel and when you come back it's dry. You set out a bowl of water for your dog and when you look again, the water level in the bowl has dropped even though Woofy hasn't been nowhere near the bowl. Where did the missing water go? It evaporated. That means some of the liquid water in the towel or bowl changed into an invisible gas called water vapor and drifted away into the atmosphere. Notice that evaporated contains the word vapor. The same thing is constantly happening with oceans, lakes, rivers, swamps, swimming pools, and everywhere water is in contact with air. Liquid water changes into gas when water molecules get extra energy from a heat source such as the sun or from other water molecules running into them. These energetic molecules then escape from the liquid water in the form of gas. In the process of changing from liquid to gas, the molecules absorb heat, which they carry with them into the atmosphere. That cools the water they leave behind. Yeah, here we have a very sophisticated picture of what's going on. Heat causes some of the liquid water from places like oceans, rivers, and swimming pools to change into an invisible gas called water vapor. This process is called evaporation, and it's the start of how clouds are formed. Let's just go through the whole thing in order to make a point. And if, which I highly doubt you never heard about this uh, theory, how clouds form. After this, you know how clouds form, at least according to NASA. Science. The air can hold a certain amount of water vapor depending on the temperature and the weight of the air, or atmospheric pressure. Yeah, that's something people have to wrap their heads around, but we won't dive into that now. The higher the temperature or atmospheric pressure, the more water vapor the air can hold. When a certain volume of air is holding all the water vapor it can hold, it's said to be saturated. What happens if a saturated volume of air cools or the atmospheric pressure drops? The air is no longer able to hold all that water vapor. The excess amount changes from gas into a liquid or solid, ice. The process of water changing from a gas to a liquid is called condensation. And when gas changes directly into a solid, it is called deposition. These two processes are how clouds form. Condensation happens with the help of tiny particles floating around in the air, such as dust, salt crystals from sea spray, bacteria, or in that case also viruses, or even ash from volcanoes. Those particles provide surfaces on which water vapor can change into liquid droplets or ice crystals. A large accumulation of such droplets or ice crystals is a cloud. Dust and other particles floating in the air provide surfaces for water vapor to turn into water drops or ice crystals. The tiny drops of water condense The tiny drops of water condense on the particles to form cloud droplets. Clouds are made up of a bunch of cloud droplets bundled together with raindrops. We usually think of clouds as being up in the sky, but when conditions are right, a cloud can form at ground level too. Then it's called fog. Yeah, here we have the proof for, like, where heaven starts. Yeah, there are many people walking around on Earth hoping that after they die, they finally go to heaven if they were behaving well. But that's a goal and hope of many people. Like I said in one of my presentations, if you never walked through fog, you've walked through a cloud. So that's where heaven is. It starts beneath your feet, whether there is fog or not. Fog can be seen at the top of this image of the 525-foot tall vehicle assembly building at NASA's Kennedy Space Center in Florida. Although the basic idea of cloud formation is easy to understand, there is much more to learn. Peek beneath the cloud's fluffy exterior and you will find a world of complexity. In fact, clouds are considered one of the most challenging aspects of climate science. Yeah. uh, I tried to make this a short video. That's because truly understanding clouds requires a deep understanding of the entire atmosphere. Scientists are working to increase their understanding with the help of instruments such as those on NASA's ICESat-2, PACE, and other satellites that observe different aspects of clouds. NASA has a fleet of spacecraft that orbit Earth called satellites. Many of them study clouds, weather, climate, and more. The better we can understand clouds and the atmosphere that creates them, the better we can find out what's happening to our climate. All right, so this is, I don't know if this is for kids or whatever, but that's not only a very, very simple explanation, but also there's like, let's go to this where we have, here it is. Water droplets, water vapor, dust. It needs static electricity in order for the water vapor to uh, get attached to the dust particles. So it's electricity after all. It's the static charge of those dust particles that attracts the water droplets. There's not one single word of electricity in this little funny article. Okay, but now I showed you how officially clouds are formed. we have dust, we have water vapor, and it just get more water vapor and it forms drops and then you get a cloud, okay? And it needs heat from the sun, water, and it evaporates. So now, let's go back to our volcano. Let's just look at this little part. You can see the eruption. Everybody's looking at the eruption, okay? Yeah, it's massive. And that's some older footage. And I was about to make this video already a few times, but I didn't somehow manage. But now I have to interrupt this quickly because we will use our magnifier here and we are watching this area here. Yeah, I know everybody's watching the volcano, but we are watching this area here. Let's zoom in just let's 25. That's from last year, this footage. I have seen this many times. I think I already recorded this many times, but this time I just thought I'd make it straight ahead. Let's watch this area here. Let's put up the volume in order. We are watching this now a little bit slower, and I think it's funny how it sounds. I don't know if you can see that. And it's a pity that we have this writing here because you can see how they are moving rather quickly here in the background. Now let's go to the beginning and let's put the volume off. I don't know if you can hear it even. Now let's watch it again. And I want you to ask yourself about what we just heard. Where is the water vapor? Heat causes some of the liquid water from places like oceans, rivers, and swimming pools to change into an invisible gas called water vapor. This process is called evaporation, and it's the start of how clouds are formed. Because I claim clouds are plasma, and this, how to put it, you only get plasma with electricity. And for those who know a bit more about weather and atmospheric conditions and all this kind of stuff, you probably know that we have a lot of electricity in the sky. There is a huge electric potential above our heads, around us. And we have layers in our atmosphere. Meteorologists call them pauses, tropopause, mesopause, what they are, whatever they are called. But in plasma terms, we should call them double layers. So, yeah, someone could argue, yeah, we have maybe the sun shining here, which evaporates some water. But we also have this volcano erupting. And I have been making many, many videos about volcanic plasma. And there are like Some people are talking about electric volcanoes or the electrification of volcanoes. But now let's just look once again at this area here. Let's go back. The exclusion zone. Yeah, easy water. Greetings to Gerard Pollack. Now that's a quarter of the speed. Does it look to you that the sun is heating up some river, lake, or pool somewhere and it forms these clouds? And here, obviously, we have also some kind of layering. There's more going on here. And this is just happening probably. Let's check out this timestamp. So now here, there is basically nothing here. It already starts, but we just focus on this area for simplification reasons. 5:53, nothing. 3 minutes later, many clouds. Now we have even more. And then it starts to build up here over the surface, over the ground. And I think there's some huge electric current flowing through the surface or beneath the surface that ionizes the air and it forms the clouds because it moves around after that. So from having nothing, 5:53, until the whole thing here just above the ground disappears. What? 9 minutes or 10? Let's say 10 minutes. Within 10 minutes, all that happened and it disappeared again. To me, it seems that there isn't really sun shining on this area here. So now you can ask yourself once again about the long explanation. It's not a long, it wasn't a long explanation of how do clouds form. Probably we have to take this seriously. Or how it's actually probably meant because, yeah, NASA asking, how do clouds form? Okay, NASA, if you want to know, give me a call. I can explain it to you. Might be a big statement, but bring it on. Give me a chance, and I will tell you a few things. I have done it already many times, but yeah, clouds are plasma because they are formed by electricity. Thanks